Hey there, my name is Alejandro, and welcome back for day 138 of me doing the Daily League Code Challenge until I reach 1 year's worth of Greek contributions here on GitHub. So today's problem is for December 1st, 2024. Let's get straight into it. Okay, today we get a leak code easy. Freaking finally, after 3 hearts in a row, this is very much well needed. Okay, problem 1346. Check if n and its double exist. Given an array of integers, given an array R of integers, check if there exists two indices I and j such that I doesn't equal j, okay, 0 less than or equal to i's, okay, they're in the array, and R of I is equal to 2 times R of j. Oh, okay, that's it. Okay, example, R equals 10 to 5, 3. Output true for I equals 0, j equals 2, R of I equals 10, j equal to 2 times 5. Wait, okay, this is just contains duplicate, but instead of duplicate, it's double. Okay. I guess we can do for each number. Okay, so what should we do? Like for each number, put its half and its double into a hash, or no? Okay, wait. For each number, we want to check if its double is in there, right? Okay. We can just do that, right? So we can keep track of a scene set. For num in R, double equals 2 times num. If double in scene, turn true. Scene.add num. Return false. Is this literally it? Bruh, no way. Okay, submit. Wrong answer. Okay, why is this wrong? So expected true and so on. So here, okay, 7 and 14. Okay, so I should add the halvings or something. So yeah, so 7. Okay. One way we could do this is sort and so on. Okay, but this is simple enough, right? What do we add? We add the double. Okay, let's use this test case. If I add the double, well, it would work in this case, obviously, right? 7 is like, oh, this double is 9 there. But okay, we could do scene.add num in the double, right? Or wait, let me think about this. We could also add its halvings and so on, right? Like we have many ways to essentially get around this. So for this, what can we do? We could add the halvings. Okay. So the point is that when we get to 7, we see 14 is 9 there. I mean, we could just do something like this, right? We could just do set of R. Right? And then there we go. Like this would work. Okay, and now we can submit this. This does not work? Okay, you literally have all the numbers in here. Expected false, we got true. Why? Oh, 2 times 0. Oh gosh, okay. Wait, but 2 times 0 is in there, right? Oh, but it I is equal to j, right? 0. Count zeros equals r dot count of 0. Equals 0 and count zeros is less than or equal to 1. And pass. Else return true. Put this test case in here. Whoopsie daisy, whoopsie daisy, whoopsie daisy. Okay. Yeah, pretty much. Okay, there we go. Bada bing, bada boom. completion streak, 138 days. Consistency is key. See you tomorrow. And beats 100 ms. Very nice. Very cool. Okay. Obviously, we can make this a little bit cooler. The point is that, like, you know, this is all overall O of n, right? This is O of n. This is O of n. This is O of n. So it's like all O of n. And I was like, okay, in terms of asymptotic complexity, we have an optimal solution. But obviously, you know, we can do things a little bit better. Blah, 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 blah. I mean, yeah. You have to get around the zeros case, right? Scene is equal to a dict. Count zeros. Yeah, I mean, like, you can do this all in one pass, right? So it's instead of this, it's like, you know, scene is equal to set. Count zeros is equal to 0 for num in R. Scene dot add num. Count zeros plus or equal to num is equal to 0, right? So it's like, this is also O of n, but that way we do it like in one passing, but it might end up being a little bit slower anyways, right? And so it's like, here is if double in scene and not the case that, you know, then return true. Right? We might as well put this here. Right? So something like this would also work, right? And okay, I guess it still beats 100%. We might as well do things this way. It's just like a little bit more lines of code, but there you go. We might as well put this in parentheses. We can use De Morgan's law here. Double doesn't equal 0. Or count 0. There we go, so this also works. There you go, it's like, you know, tiny micro optimizations. And yeah, okay, so it actually doesn't like that. Dang. Dang, it doesn't like that. Really? But now it does? I guess so, okay. For some reason, that's a little faster. Okay. Okay, no worries. Okay, so as always, on my videos, I do a quick recap if I was able to solve the problem. So with this one, essentially, okay, the very first thing that came to mind is contains duplicates. It turns out this is a tiny bit more trickier than a problem that contains duplicates. Essentially, the thing that I recognize is like, okay, you know, if the double of another number exists in the in the array, then it's like, okay, we must figure out what that number was, right? So this is almost like find duplicate, but instead of, you know, finding a duplicate, you find a number's double, right? And so the way that I was able to do this essentially is like, okay, let's take every single number in R and let's put it into a hash head, right? So one way you could have done this is like, you know, I call my hash head scene, so you could have done scene of R, but I also want to count the number of zeros, which I'll explain why. So instead of doing, you know, scene is equal to set of R and count zeros is equal to R dot count zeros, both of which are O of n operations, which means that total asymptotic complexity of this would be O of n, which is fine in terms of, like, which is optimal in terms of asymptotic complexity, but I was like, okay, you might as well only do one O of n loop instead of two O of n loops, if you can, right? So I got rid of this, and so I just said, okay, let's initialize scene as an empty hash set, let's initialize count zeros as 0, and then for every single number in R, we'll add that number to our hash set. That way we have, you know, a hash set of all the numbers inside of our array, and as well as, like, you know, every time if the number is equal to 0, I'll increment count zeros by 1, otherwise by 0. There you go. So that way I get the number of zeros, right? And then what I do is essentially very simple, right? I loop through every single number in R, in array, and so here I have a hash set that includes every single number in array, right? So for every single number in R, I can check, like, okay, let's compute its double, which is going to be what? It's going to be 2 times num, right? That's pretty much it. That's just the double of the number. And now let's check, okay, we want to check, okay, given an array of integers, check if there's 2 indices such that, you know, one is the double of the other, right? So we have access to every single number in R inside of a hash set in O of 1 lookup times. And so now we're going to loop through all the numbers in R, and we're going to compute its doubles for each number in R, right? And we say, okay, is that double also in the array? Which we can do by checking, is that double in our scene hash set, right? And so if a current number's double is inside of the hash set, then we're done, right? The only special edge case is with the number 0. Why with the number 0? Because with the number 0, if you do 0 times 2, you still get 0, right? And here he wants you check if n and its double exists, but it must specifically be different indices, right? And so it's like, okay, if there is a 0, right, we want to make sure that, yeah, obviously, if there's a 0 in the array, right, like for example, in this case over here, there's a 0 in the array, but if there's not another 0, then yeah, 0, the double of 0 is technically in the array, but at the same index, right? This 0's double is itself, right? But you must find 2 different indices such that one index is the double of the other, right? So in this case, if there's only one 0, then even though its double is technically in the array, since it's its own index, it cannot, you cannot consider this as a valid solution, right? So 0 is the only number that when you double it will equal itself. So if there are zeros, you must check like, hey, is there at least 2 occurrences of zeros? Because at least that way it's like, hey, we can pick one of the zeros and say the double is the other 0, right? And that way it's like you solve the problem and you can return true in that case. So if the double isn't seen, right, and that double happens to be a 0, right, because 2 times 0 is 0, then it's like, okay, I only want to return true here if there's at least 2 zeros, right? So at least 2 zeros means greater or equal to 2. The opposite of that is less than 2, or less than or equal to 1. So that's why I say, like, you know, if double is equal to 0 and count of zeros is less than 2, so less than or equal to 1, then I don't want to return true right here. So it's like I only do it if double isn't seen, and it is not the case that double is equal to 0 and there are less than 2 zeros, right? Because if double is equal to 0 and there's less than 2 zeros, then that's not a valid solution, because again, even though it's its own double, it must be at different indices, right? So only if the double isn't seen and it is not the case that it is it is a 0 and there is only one 0 in the array, right? And in that case, I return true. And again, I return true in most of the times, like, you know, this won't matter because double is not equal to 0. Otherwise, it's like, you know, when I compute a number's double, if I see that, oh, it is already in the seen hash set, right, which is a hash set of all the numbers inside of the array R, and it's like, okay, if for any number its double is in the seen hash set, then I will return true immediately, right? It's just that we also have to check for the case, like, okay, if the number is 0 and there's less than 2 zeros, we actually can't consider that, right? That's just a tiny edge case. Otherwise, if we've gone through every single number in R and none of the doubles as a unique separate index for the zeros case, but if none of the numbers doubles exist in the array itself, then in that case, we just return false because we've exhausted every single possible number, and for every single number, we've never found one whose double exists as well inside the array or the seen hash set. And so in that case, we just return false, and bada bing, bada boom. And as we can see, it is a nice and efficient solution. So hopefully that solution made sense. And yeah, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I'd highly appreciate it if you left a like or a comment. Otherwise, I'll catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.